Hello aspirant, today we revise modern physics in less time and it is a high weighted chapter and you can expect 4 to 5 questions in your Neet exam. Okay, so we can start lecture. And so first is photoelectric effect. What is photoelectric effect? Photoelectric effect occur when light fall on metal surface and electron will emit, and electron will emit only if frequency of light is greater than the frequency of metal surface. Okay, so for frequency of metal surface we define threshold frequency. What is the threshold frequency? Threshold frequency is a minimum frequency from which photoelectric effect can be started. Okay, and next is work function is minimum energy required to remove electron from metal. And next is cutoff wavelength is the maximum wavelength up to which photoelectric effect will occur. Okay, next is Einstein equation of photoelectric effect, and it is a most important equation. Okay, that is incident energy is equal to work function plus maximum kinetic energy, and incident energy also can be written as h mu, and work function is h mu naught, and kinetic energy is equal to half mv square. And we also can write kinetic energy in term of potential is equal to ev. And for fast calculation we have to remember this formula, that is E is equal to 10420 upon lambda electron volt, where lambda is nanometer. If lambda is angstrom, then we use 12 upon 42 upon lambda electron volt for incident energy. Okay, next is important point related to photoelectric effect. First is intensity is directly proportional to the number of electron emit, and that is also directly proportional to the photocurrent. So if we increase intensity, then photocurrent increase. And frequency of light is directly proportional to kinetic energy of electron, and kinetic energy of electron is directly proportional to the stopping potential. And next is energy of each photon is h mu. So from unitary matter, energy of n photon is nh mu, and power is np into ep, where np is the number of photon emitted per second and ep is the energy of photon. Okay, so we now we do graph, important graph related to photoelectric effect. First is stopping potential versus frequency. Stopping potential versus frequency. First is stopping potential versus frequency. So stopping potential is directly proportional to the frequency, so curve will be like straight line. Okay, next is intensity vs photocurrent. Intensity is directly proportional to the photocurrent, so curve will be like straight line also. And photocurrent versus time, current is not dependent photocurrent is not dependent on time, and after some time it will get saturated like this. Okay, and next is photocurrent versus frequency. As we know that photocurrent is only depend on intensity, so photocurrent does not depend upon frequency, so it will be constant. Like this. Okay, now curve is photocurrent versus voltage, where current is vary. So as we know that photocurrent does not depend upon voltage, so for every current voltage is constant, that is v naught. And it is a stopping potential, where is photocurrent is 0, Okay, now kinetic energy versus frequency curve. As we know that kinetic energy is directly proportional to the frequency, so curve will be a straight line. Okay, now curve between photocurrent versus voltage. As we know that photocurrent does not depend upon voltage, it's only depend upon intensity. So for different voltage, photocurrent is same. Okay, now now de Broglie hypothesis. For a moving particle which has mass m and velocity v, so de Broglie wavelength is lambda is equal to h upon mb, and mb also can be written as under root 2 mke, where ke is a kinetic energy, and kinetic energy also can be written as q into delta v, where delta v is stopping potential. And as we know that momentum is equal to mb, so lambda is also can be written as h upon p. Okay, and for a photon, lambda is equal to sc upon e. Remember, this is very important, and e is equal to p into c, where p is a momentum. Okay, and some most important formula related to de Broglie wavelength. If potential is given, then for electron lambda is equal to under root 150 upon v, 150 upon 150 upon v, where v is a potential difference, and also can be written as 12.2 upon under root v angstrom. Okay, for proton de Broglie wavelength is under 0.286 upon under root v, and for deuteron its value is 0.202 upon under root v angstrom. And for alpha particle, de Broglie wavelength is, if potential is given, then its value is 0.101 upon under root v. Okay, and some relation between mass of proton and mass of deuteron, and mass of alpha particle and mass of proton. Mass of alpha particle is 4 times mass of proton, remember it, and charge of alpha particle is 2 times charge of proton, and mass of deuteron is 2 times mass of proton. Remember this for calculation purpose. Next is radiation force and radiation pressure. For perfectly reflecting body, for 100% reflection, radiation force is equal to 2ia upon c, where I is intensity and a is surface area and c is speed of light, and radiation pressure is force upon area, so we put value of force from here and we will get radiation pressure is equal to 2ia upon c. Now for perfectly black body or 100% absorption, radiation force is only I upon c. Okay, only I upon c, and radiation pressure is force upon area, so its value is I upon c. And if a source has a power p, if a source has power p, then intensity at distance r due to source is power upon area. Okay, coming to the next topic is Rutherford alpha particle scattering experiment, and here is some observation on which some interpretation is derived. Okay, so first is, most of alpha particle travel through the foil undeflected, So its interpretation is the atom is mostly empty space. Okay, next is some alpha particle are deflected by a small angle. So its mean is the nucleus is positively charged as the alpha particle. That's why repulsion happen between alpha particle and between nucleus, because of same charge. Okay, and next is occasionally an alpha particle travel back from the foil. So its interpretation is nucleus carries most of the mass. Okay, so maximum mass exist at nucleus, that's why more repulsion happen. That's why electron will alpha particle will get deflected 180 degree. Okay, and some drawback of Rutherford model is, first is could not explain spectrum and could not explain stability of atom, and it's have two application. First is closest distance of approach. When alpha particle thrown from velocity v naught, when it reaches distance r naught, its velocity will be 0. So loss in kinetic energy is equal to gain in potential energy. After solving it, we will get value of r naught, that is closest distance. Okay, next is impact parameter. Impact parameter is that is directly proportional to the value of cot theta by 2 and inversely proportional to the kinetic energy of alpha. Okay, if impact parameter increase, then stability decrease, and impact parameter decrease, then stability increase. Okay, next is Bohr model. Bohr model is only for one electron system or single electron system, and its postulate is first is centripetal force is equal to electrostatic force, and second is angular momentum is h upon 2 pi का इंटीग्रल मल्टीपल होता है, दैट इज बोहर क्वांटाइजेशन. एंड थर्ड इज during excitation and de-excitation fixed energy either released or absorbed, that fixed energy is equal to SI by lambda. Okay, and some important point related to Bohr model is here. First is radius of nth orbit, that is 0.529 n square by z angstrom. Okay, and radius of nth orbit is inversely proportional to the mass, and velocity of nth orbit is 2.18 10 की power 6 into z by n, that's unit is meter per second. And angular velocity is vn upon rn. After putting the value of vn rn, we will get that angular velocity is directly proportional to the z square and inversely proportional to the n cube. Okay, and next is time period of nth orbit. Okay, time period of nth orbit is 2 pi upon omega n. After putting the value of omega n from here, we will get n cube upon z square, that is time period of nth orbit is directly proportional to the n cube and inversely proportional to the z square. And for total energy is equal to 13.6 into z square upon n square, and its unit is electron volt. Okay, and current of nth orbit is q upon t, where t is the time period of nth orbit. And after putting the value of time period, we will get relation in current and nth orbit and atomic number. Okay, so next is spectral series. So there are 6 spectral series. First is Lyman, second is Balmer, third is Paschen, fourth is Brackett, fifth is Fund, and sixth is Humphrey. Okay, and Lyman series lying on ultraviolet region, and Balmer series in visible region, Paschen series in infrared region, and Brackett series lies in infrared region, and Fund series also lies in infrared region, and Humphrey series also lies in infrared region. And here are some energy level that you have to remember first. Speed calculation. Okay, and next is when electron transit from n2 to n1, it will be emit wavelength of lambda, that's value is 1 by lambda is equal to rz square upon 1 minus n1 square minus 1 upon n2 square, where r is a Rydberg constant, that's value is 109677 centimeter inverse. And for fast calculation, we have to remember value of r is 1 upon 91 nanometer inverse. Okay, and next is number of spectral line emitted. So total number of line emitted when transition from n2 to n1 is equal to, क्या होगा इसका, टोटल नंबर ऑफ स्पेक्ट्रल लाइन फार्मूला डेल्टा एन इंटू डेल्टा एन प्लस 1/2, वेयर डेल्टा एन इज इक्वल टू n2 minus n1. Next is nucleus and nucleon. So radius of nucleus is r is equal to r naught into a to the power 1 by 3, where a is mass number and z is atomic number and x represent symbol of element. Here r naught is constant value, that's value is 1.2 Fermi meter. Okay, and volume of nucleus is 4 by 3 pi r cube. After putting the value of r cube, we will get 4 by 3 pi r naught cube into a, and its value is constant, so v is only depend upon mass number. Okay, so next is density of nucleus. Mass of nucleus and volume of nucleus. After putting the value of mass of nucleus and volume of nucleus, we will get constant value, and density of nucleus is approximately 10 to the power 17 kilogram per meter cube. And next topic is Einstein energy mass relation and mass defect. So formula of mass defect is z into mass of proton plus a minus z into mass of neutron minus mass of nucleus. Okay, where z is number of proton and mp is mass of proton, and a minus z is number of neutron and m is mass of neutron, and m upon capital N is equal to mass of nucleus. Okay, and formula of binding energy is equal to delta m into c square, delta where delta m is a mass defect. If unit of delta m is coming in mu, then binding energy per nucleon is delta m into 931.5 mega electron volt. Okay, and stability of nucleus is directly proportional to the binding energy per nucleon. Okay, next is Q value of nuclear reaction. If reaction is A plus B to C plus D, then Q value is mass of A plus mass of B minus mass of C minus mass of D into C square, or we can also write it in term of binding energy. Q value is equal to binding energy of reactant minus binding energy of product. Okay, remember this formula, that's very important. Next is radioactivity. Okay, so what is the radioactivity? Spontaneously unstable nucleus get disintegrated. Spontaneously unstable nucleus get disintegrated, so this phenomena is known as activity. And activity equal to minus dN by dt is also known as decay rate. And unit of activity is dps, decay per second, and its other unit is becquerel, curie and Rutherford. 1 becquerel is equal to 1 dps, 1 curie is equal to 3.7 10 to the power 10 dps, 1 Rutherford is equal to 10 to the power 6 dps. Next is radioactive decay law. radioactive decay la if nucleus A disintegrated into B, so activity is directly proportional to the number of active nuclei. Okay, so minus dN by dt is directly proportional to the n. After removing reciprocal sign, we will get a constant where is decay constant lambda, and it's also can be written as AC value lambda n. After integrated this term, we will get n is equal to n naught e to the power lambda t, and it's also can be written as AC is equal to n naught e to the power minus lambda, where n naught is number of nuclei at t is equal to 0. Next is the half-life is equal to t half is equal to ln 2 by lambda, where lambda is decay constant, and we all know that value of ln 2 is 0.693 by 0.693. Okay, next is radioactive decay equation in term of t half. So here we put value of lambda from here. Okay, so after putting the value, we will get n is equal to n naught upon 2 the power t upon t half. Okay, and next is alpha decay. So when alpha decay happen, then mass number is decreased by -4, and atomic number is decreased by -2. Mass number is decreased by -4 and atomic number is decreased by -2. And beta decay, in beta decay 2 decay, first is beta plus decay and second is beta minus decay. In beta plus decay, atomic number is same and mass number is same, and atomic number will get decreased by -1. And in beta minus decay, mass number is same and atomic number increased by +1. And in gamma decay, atomic number and mass number both will be same. Okay, and here is some terminology. E minus is electron and E plus is a positron, and V is a neutron, and V bar is equal to anti-neutron. V bar is anti-neutron. Okay, so this is the lecture. Okay, we will complete in less time, and you can see video, and if you wanted to PDF, then comment. Okay, thank you.